Hello, welcome back to another episode of Mr. Walker's Apes. Today we'll be covering geology, primarily plate tectonics and the rock cycle. So this is just a very general overview of geology because geology is actually a really, really big field. I mean, you can major in geology and go become a geologist. And then within geology, there's different types of geology, like hydrogeology or mineralogy, and all these other things. So this is really just a brief overview um, to get some of the main points across. Since a lot of this stuff you probably have had throughout your education already. So, plate movement. Basically, the Earth is made up of three pieces: the core, mantle, and crust. Um, and the crust is moving, the core is moving, the mantle is moving. All of these things are moving all the time. So if we work from the inside out, we start with the core, which of course is, just this giant molten fluid metal. It's just melted metal, primarily nickel and iron. And it's what generates Earth's magnetic field, which is what, when you get a compass, it points towards magnetic north, things like that. It's very, very dense, very, very hot. Um, and so, and it's spinning, and it's constantly spinning to generate the magnetic field. The mantle is the middle piece. It goes around the core. It's made up of two pieces, the asthenosphere and the lithosphere. Um, Also very hot, and the lower part of the mantle, the asthenosphere, is very much like the core. It's liquid. A little bit cooler though, and not quite as dense. And then the outer part, right up against the crust, so the piece between the asthenosphere and the crust, is more rigid. It's solid rock. And of course, the crust, that's what we walk around on. That's what we see the mountains and the bottom of the ocean and all that stuff. Um, you have the continental crust, which of course is the land, and the oceanic crust, which is the oceans. And because the oceans are full of water, there's much less land. So it's thinner near the ocean, and so we get lots of volcanic activity under the ocean. So forces that raise the surface. There's a theory in geology that's very well supported that is the theory of plate tectonics, and that is that Earth's surface is made up of these large plates that we call tectonic plates that are always moving. They kind of float around on top of liquid rock, and there's what create things like the San Andreas Fault in California, the Appalachian Mountains in eastern United States, the Rocky Mountains in central United States. All these things because the plates are moving and mishing together and separating out and doing all sorts of neat things. Um, so as these plates move around, of course, it rearranges the surface of the Earth, and it is theorized that at one point all the plates were together, and we called that Pangea, and now they're all separating out and moving away from each other. Or some of them are pushing into each other, like the Indian plate is pushing into the Asian plate. So here's a little graphic of this. So when they're all together there, that's Pangea, and then they separate out. Um, Obviously Europe is missing here. This is not the best animation, but it's there. You can see India there turns up into Asia. So we've got this is India here, and then it mishes up into Asia. South America used to fit into Africa. If you look at it like a puzzle, that's kind of, it kind of makes sense. So over time, these things change. So you can see that North America is slowly moving away from uh, Europe. So the Atlantic Ocean is getting slightly bigger every year, and the Pacific Ocean is actually shrinking a little bit every year. It's about I think it's like a centimeter a year or something. So basics of rock cycle. It's pretty simple. It's all based on density of something. So the more dense it is, it sinks, and the less dense it is, it rises, just like air. So, as things cool down, they become very dense. All right. So if we start up here, we go with cold, dense material, it falls back down. And of course, as it gets close to the core, it heats back up. And when you heat something up, it becomes less dense. So it rises back up and it cools and it falls back down. It rises back up, cools, falls back down. Okay. That's your basic rock cycle. Just going up and down, up and down, up and down. Uh, and you can see here, as you do this, it's what causes these plates to move apart. So we've got a plate here and a plate here, and where the magma is rising up and cooling, it's creating new rocks. So it pushes the plates apart. Okay, so the plates are moving further away, and where you have these converging, okay, so this is rising and then moving this way, it's pushing into the other plate. Um, and so you start to form mountains, and every now and then you get one of these little magma intrusions, which can create a volcano and things like that. But this is your basics, okay? You just need to remember, dense stuff sinks, just like in air or water or anything like that. If you don't believe me, just get a beaker and put it on a Bunsen burner. All right, turn the Bunsen burner on, of course, and heat just one side of the beaker. Okay, so just try and heat one side of it, and put food coloring on the side that is not being heated. And what you should see happen is that the food coloring will sink because it's on the cold side, and then as it gets closer to the bottom, it becomes warmer, so it moves towards the warm side and back up. And it's exactly what's happening here inside the Earth. It's just with the Earth, it's a much, much larger scale. So just more pictures of things moving. So we've got that whole uh, convection current going, rising, falling over here in the mantle in the asthenosphere. You've got the lithosphere. So where things are spreading, it's divergent. Where they're coming together is convergent. We're going to show pictures of all these words that I'm talking about. And you can see just all the stuff that goes on in the Earth. Here's the subduction zone. Lots of really cool things going on. And this is why geology is such a big field. I don't think that geologists will ever be without work because rocks are so important, and this whole cycle has not quite been figured out completely either if you want to do research. So here we go. All right, so this is divergent. Okay, divergent, meaning to divide. Okay, so divergent is dividing, and we're pushing the plates up. They're not really pushing. They're just moving apart. Okay, and what this creates is ridges. Okay, so you've got magma coming up, cooling, and this is under the ocean, which is why it's blue. Okay, coming up, cooling, and as it cools, it forms these ridges. Now, you might say, okay, well, why don't we just call those mountains? These are ridges because they're all parallel, all right, and they're also moving away from a divergent place. Okay, so this is a trench. Okay, like the mid-Atlantic trench. All right, and then these are the ridges, like the mid-Atlantic ridges. So if you look on some maps, like if you go to Google Earth and you go to the middle of the Atlantic Ocean, you're going to see this. Um, and so we have ridges that all go parallel to each other, and as they go further away, they start to get eroded down, and so they eventually become sand again, and then that sand sinks back down, and on and on and on. Okay, so Iceland, of course, is right in the middle of the Atlantic Ocean, so it falls right on that fault line between the two plates of the Earth, and so here we have a divergent boundary right here in Iceland. So you can see exactly where these rocks got split and everything. So it's kind of neat. You get little geysers and stuff going on. All right, here is the opposite. This is a convergent, okay, coming together. Uh, so we're pushing two things together, which creates a subduction zone. The one that is more dense than the other will go under it, okay? So the more dense plate goes underneath of the less dense plate. This often results in mountains, okay? So you'll get a trench and mountains. And these mountains can be formed either because of the plates actually pushing together, this one going this way, this one coming this way, or magma coming up through because you're cracking the crust. It's very difficult to do. All right, so just for a second, take a second here. With your hands, all right, make these plates, okay? Like, put them in front of you, put your hands in front of you, palms facing you, and pull them apart from each other. So overlap your fingers and then pull them apart from each other and say divergent. You are dividing your hands, okay? Uh, then bring them back together, overlap your fingers, okay? And as you do that, all right, as you try and overlap your fingers, like run your fingers into each other, you'll notice that you get lots of force there. You can't push, one finger through the other finger. And so as a result, you have to bend your knuckles. Okay, and the stronger hand will win out, and then you bend your knuckles and you get mountains. All right, so that is convergent. So you can use your hands as models for these plate tectonic things, which is handy on a test because you don't get anything else on a test. All right, and nobody, people look around the room and be like, "Oh, you're crazy, you're using your hands," but you know what? You'll get it right. So that's what matters. All right. So we've got these divergent things. Now, this is showing a couple of things. First, you have divergent, divergent. Okay, but then you've got this thing going on in the middle, and it's labeled transform fault. Okay, a transform now is when you've got two plates that rub side by side. All right. So you can take your hands and rub them together side by side, like you're seeing, here. So you put one hand like this, one hand like that, and rub them next to each other. That's a transform fault. Okay. Oh, and let me go back. That results, when you have a transform fault, that results in an earthquake. And that's because they don't really slide past each other all that well. They generate a lot of friction. And so as you generate that friction, eventually the rocks will slip. And when they slip, you get an earthquake. So California has lots of earthquakes, especially Southern California, because there's a major fault that runs through there, and it is the San Andreas Fault. That is a transform fault. All right. Uh, so uh, as those plates, okay, the North American plate and the Pacific plate slip past each other um, on a transform fault, that generates a lot of earthquakes. Some pictures of volcanoes because these are what happen when you get leaks, okay, through the crust. And so, once again, the rock cycle, okay. This is hopefully something you saw in third or fourth grade, hopefully again somewhere in middle school. And so now we have the full rock cycle again. This is really basic here. Now there are lots of other things that can happen during this rock cycle, but as long as you get the basics, you'll be fine for environmental science. So you can pick anywhere to start. It's a cycle. So let's just start with igneous rock. Okay. Now igneous rock forms from volcanoes. All right. So that's why igneous rock is next to the volcano. And over time, the weather weathers rocks. Weathering means it breaks down. Okay, so we're going to break this down into soil, which is going to erode the next time it rains. As it erodes, it will deposit somewhere else. We cannot get rid of the dirt. Right? It's not going into space or anything, so it's going to run down the mountain and into the water. And in the water, it will settle. So as it settles, we create sedimentary rock. Sedimentary rock is formed from sediments. Sediments are another word for eroded soil. So igneous rock erodes, comes down into the water, and thus becomes sedimentary rock. So sedimentary rock is formed in lakes, the ocean, um, very old ponds. Okay, where anywhere where the water is generally still. Okay, it's not going to form in a river so well. Um, so now we've got our sedimentary rock, and with heat and pressure, we can form metamorphic rock. So let's say that this sediment, comes down the mountain, goes in here, it settles, it goes to the middle of the ocean, it's under a ton of pressure, it gets under a lot of heat, it's very dense, it sinks, it gets metamorphized, it changes. So we're taking something like sandstone, okay, which is just, you probably have seen sandstone lots around your schools, maybe, all right, depending on where you're at. And so it looks just like sand particles all glued together into a rock. Now, if you squeeze that. Okay, you put it under a lot of heat and pressure, and you squeeze it, you'll start to get something that looks like this. Okay, notice the banding. Okay, you get lots of bands because it's taking those sand crystals and squeezing them to less than the width of a human hair. And so you get these bands. Now, of course, if that metamorphic rock completely melts, okay, not just heated, but actually melts, it becomes magma. Once it's melted, it loses all its structure. It looks like none of these, so we call it magma. That magma can come up through a volcano and thus become igneous rock again, and so you start this whole big cycle over again. Now, of course, you can break this cycle in lots of different places. You could have metamorphic rock that comes to the surface because of the way that plates work, and then it goes straight to weathering and back to sedimentary rock. So you can go sedimentary, metamorphic, back and forth all day and never hit igneous. If it has to come through, it has to be melted and come through a volcano to become igneous. And then of course igneous could skip erosion. Okay, it could just like come out, fall right back in. So shoots out of the volcano, cools down, it's igneous rock, falls back into the magma, starts getting heated up and pressure, and that's metamorphic. And so you get this little mini cycle going here also. So it's really 3 cycles within 1 cycle, and we call it the rock cycle. Okay, so that's it for your little mini geology lesson here. Uh, just go back, study these pictures. There's not a whole lot to them. If you study volcanology, then you're going to be probably get a undergraduate degree in geology and then go get a master's, a PhD in volcanology, something like that. You're going to study a lot of these things. Now, I just say, there's a lot of stuff here with geology that we didn't talk about, like mineralogy. A rock is a cluster of minerals. So this here would be like granite. And each of these different colors is a different mineral. So those minerals all together form the rock. Uh, and so you could study all that sort of stuff, and they have some fun names in them, like quartzite, and so there's lots of different minerals to look at. All right, so I think that's it for your mini, like I said, your mini lesson on geology. We've got to cover a little bit more, uh, but that's in mining, so it's not such a big deal. So I hope you learned something, and I'll see you next time.